A warm welcome to the fourth film in our Foundations series. In it, we explain how simple concrete and reinforced concrete foundations are constructed. Foundations are classified according to the way in which they transfer loads to the ground. Individual footings transfer point loads, strip foundations transfer linear loads, and raft foundations transfer surface loads. The simplest type of foundation is an unreinforced footing, that is, one that contains no reinforced concrete. It requires no particular dimensional accuracy or surface characteristics, and shuttering is therefore unnecessary. The concrete is poured directly into straight-sided trenches. Here you can see sections excavated in the Wolfsburg foundation pit for unreinforced foundations. Where foundations are to be strengthened using reinforced concrete, the reinforcing cages, made up of steel reinforcing bar or rebar, and stirrups, must be completely encased in concrete. This is done by sheeting out the sides of foundation pit or trench with formwork into which the concrete is then poured. Here you can see how bracing elements are fixed to the top of the formwork sheets to prevent them from moving apart. The steel reinforcing bar is laid on a very thin layer of viscous concrete, which we call lean concrete. Reinforced concrete foundation rafts also require a lean concrete blinding layer to ensure that the rebar does not come into contact with the ground. The ends also need to be shuttered. Foundation rafts distribute loads over a wide surface area and are therefore well suited to transferring loads into ground that has a poor load-bearing capacity. Specifying the dimensions of foundations is the work of the structural engineer. As an architect, however, there are two important things you should know about the dimensions of foundations. Firstly, for practical reasons, so that a layer of thermal insulation can be laid on top of the foundation, for example, a foundation should always project at least 5 centimeters past the rising wall. Secondly, the underside of a foundation slab should be deeply enough embedded in the ground to lie below the frost line. This prevents ground frost from penetrating beneath the foundation and causing it to lift. This phenomenon is known as frost heave. In Germany, the minimum depth is 80 centimeters, but it may be significantly deeper in colder regions. Summary. Foundations are classified according to the way in which they transfer loads to the ground. Individual footings transfer point loads, strip foundations transfer linear loads, and raft foundations transfer surface loads. Specifying the dimensions of the foundations is the work of the structural engineer. However, architects should know that for practical reasons, a foundation should always project at least 5 centimeters past the rising wall, and that the underside of a foundation slab should be embedded at least 80 centimeters in the ground to lie below the frost line. This prevents frost damage. Why not take a look at the fifth film in our Foundations series? In it, we discuss what happens at the point where the foundations meet the ground.